Sweet.
Yeah, baby. Now I have to mute something. I have to. I hear an echo. I think through you.
Do you want me to put headphones on?
Yeah, or mute YouTube. Are you watching on YouTube too?
Oh, right. Well, that happened before, but my YouTube's muted now.
All right. Are we better now?
I don't hear any kind of echo. I don't know if you.
Yeah, as soon as I started recording, I got the echo. So I have to mute something.
I can do it with headphones, no problem. If it's me.
Yeah. It should be streaming now.
Okay. There's no audio coming through on my end, so if you still hear the echo, it's not me.
How about now?
How about now? What?
I don't know. Okay. I don't know why. Oh, it's because I don't have you. I have double. I had unmuted you on OBS. Say something again. There we go.
This is David.
There we go. We're all good. We are all good. So let's see. Am I connected to the stream? It says no. Copy. OBS is being weird for me today. I don't know why. I'm going to streaming. I don't know why I did that.
Streaming now, or at least I think. Yeah, it is. I can see myself. I just moved.
Okay. Yeah. I just. Whoops. I don't know what I hit. Is the stream still going?
Yeah.
All right. Well, there we go then. Yeah, I don't know why.
Crazy delay, but it's always been like that.
Yeah. Well, no, OBS is being weird. Hi, everybody. We are streaming again. It's Friday. It's Beer 30, and actually, it's only Beer 30 for me. For most people, I guess if you're on the East Coast, it's Beer 30. We just started here at my business incubator. We used to have this tradition of going and getting beers every Friday at 4:30, and COVID shut that down pretty hard, and we just made our first foray out into like having a social life again last week. So I'm now looking forward to it. It's great. So last week I got totally blown out on Friday, so apologies for everyone who was waiting for this stream to happen and we're just so disappointed when it didn't. I know that describes most of you. I had a birthday on Wednesday and then also took Thursday off, and then I was slammed on Friday. So we have David with us as we often do. I'm also trying something new. Basically, I'm going to be sharing, for the most part, if I'm sharing SolidWorks, because I was sharing it on another screen, thinking it was the same resolution and it would be better. I'm actually going to be using my main monitor. I won't have that weird drop-down issue, hopefully. And I've resized everything so that people won't be asking me to remove my picture so they can't see something or move the logo. New layout. We're improving, upping our game all the time here. So that is that. There's been a lot of work that I've done on the music box, kind of as a trial project, and David has been working on the MMX studio version. We both have stuff to share. We have opinions to bounce off each other about how we're going to do stuff, and David has some specific things to chat about in terms of how we're going to use SolidWorks for this project as well. So let's dive in. What do you want to do first, David?
We can go over the music box if you want. It's up to you.
Yeah. Okay.
I don't have any preferences.
All right. Yeah. Let's do that because I think normally that's kind of our flow, right? So just in terms of kind of figuring out how we model things and what our our process is going to be like. I started over the music box. You can see this is music box version 5. And it's because we're experimenting with the process, right? But I am now starting to treat this like we would want it to do. So we have in SolidWorks, we have an assembly. There are no parts directly in the assembly. We only have sub-assemblies. We were talking about how we're going to do this with the marble machine. And the marble machine, we're probably going to have assemblies and sub-assemblies. So there'll be no parts in the top 2 levels. You'll see I here have...
Yeah, I'd say that's pretty accurate. Sorry, I didn't mean to interrupt.
Yeah, okay, that's fine. And so here I have the paper wheel, and it's got the parts in it. Only the punch head has a sub-assembly, and that's because the part that goes across will travel with respect. It will move with respect to the larger module. So I do have a... So this one's a little simpler, but what I want to point out with, and this is kind of how I was playing with working this way, which is that if I turn all these guys off, right, I have some basic reference assembly reference material here, right? This is just the bare bones of the shape of the thing. And I don't know why it happened, but then when I added another sketch to the top level assembly for reference geometry of how things are going to line up the other way, it put this down here. It didn't put it up here with, I don't know why. It doesn't really matter, I guess.
Have you tried dragging it back up?
I have now. Oh, it worked. Why did that work? Okay. That's kind of a derp. Like, have you tried moving it? All right, yeah, good for SolidWorks. Parenthetically, I also did a thing where when I had this punch head thing, I realized I had an assembly, and then I also had this punch sub-assembly for the carriage, and I brought it into the master assembly. I was like, no, that's a sub-assembly of the thing, so I just dragged it into the other assembly, and like, hey, that works in SolidWorks. That's so nice. In any case, so we have this master reference assembly. You can see, since we have the relations, these guys only relate to each other, right? And there's not a whole lot of detail in this skeleton, right? If I turn on this guy, this paper wheel, it has its own. I'm going to drag this one up too. Can I get away with it? Will it work? It worked with the other one.
You should be able to.
Well, either way, if you can see this one has its own sketch geometry, which defines the size and the shape of this hub and a bunch of other things, right? And if you look at the references, it is only related to this first sketch, right? And I've done a bunch of things where I wanted to, like, when I make these wheel side plates, like first I made the hub, and then when I made the wheel side plates, like, it would be really easy to draw this side plate starting with a sketch that's on the side of the hub, right? And David, you can tell me if this is the wrong thing to care about or not. But like, my feeling was, like, if I deleted the hub, I didn't want to break it, right? So when I did this side plate, I made inside that its own reference geometry for where it's going to start. That was based on the that was based not on the side of the hub, but on the reference geometry that was in here. Does that make sense? Right. So I don't have any dependencies. The dependencies here are on this sketch, not on the hub, right? So as we're going through things, if we're looking for a part, you shouldn't have parts within that subassembly that are referring to each other, right? Let me show you the counterpoint to that, because I did this incorrectly in another part that I was working on today. So let me turn off this guy. So here's the paper puller. And I love, by the way, the show relations arrows. It's amazing. So here's the paper puller, and I have a... that's not... I don't want the paper puller, sorry. That's the wrong one. Punch head. And turn this guy on. Right. So here, this plate, when I drew it, I realized I wanted to kind of get it in place before the stream, and I realized I didn't have reference geometry for it. So if you look at this guy, and you look at this boss extrude and there's a sketch, this is referring to this base, right? So if I just to delete the base plate that that goes onto the music box below it, I'll have broken that, right? So we, as we go through things, we want to make sure that we have, you have some reference geometry that is in your assembly, and you're only referring to that, right? You don't want to have. Does that make sense? Is that something that we should care about?
Yes.
Okay.
Yeah. So that is actually one of the best ways of doing it. I mean, for the most part, you kind of always want your parts to look up, right, to some level above it. And if like equal parts, like two parts within a subassembly, both look to the same geometry, then they're on the same page. So yeah, that works.
Yeah. So this.
Yeah, you caught yourself. That's good.
Yeah. So this reference would be bad. It's a natural way to do it because you're picking a plane. But I do have, I do have a point in the reference geometry that I can point to, make a plane there, and then avoid having to refer to this, because if I suppress this feature, I probably will break it. Well, I don't know if suppressing breaks it or not, but if this one went away, at least, I would have broken that part, right? So anyway, that's the idea. So that's feature number one. I'm really happy with this. And by the way, so I'm also I can't show it on the stream. I've shown it to a few people privately because I'm working on a medical robot, essentially, for pathology. And this is a startup I'm joining. And I'm doing it in Fusion, and I'm doing it the same way I did it here, right? Where I have a bunch of different skeleton sketches which lay things out, and then I've made sub-assemblies, and I've been editing it, and I'm trying to basically do this workflow in Fusion 360, and it is a pain. It is and it's a mess. Anyway, I'm loving how this workflow works in SolidWorks. It's not really something where you could say, oh, if you just did it that way in Fusion would need its own workflow for doing it that way. But I am loving that I can, just pop into any of these sub-assemblies, either edit them in place. I can drag components from one sub-assembly to another sub-assembly. I'm loving that, especially having dealt with it. Anyway, so specifically on to kind of what we're doing with the music box. Let me turn off these reference sketches and let me hide these temporary planes. Again, the idea here is that we have a music box where we have one paper pulling mechanism. Which is this stepper motor down here will be driven with a belt up to here. This is vibration isolated. I've only put in the minimum geometry to make sure that it clears. I haven't done fully featuring of this. So this one will drive this roller. This roller will drive that roller via friction. These shafts will be mounted with a bearing on a sliding block. There will be a hole on the top of this plane here to push down so we can tension the two rollers against each other. And the paper will wind through. But the concept of the machine here is that this base plate here can pop in and out, and actually it may be a subset of that plate. You'll see that there is below that plate. This isn't the top of the box. The top of the box is here. So you can either put in this head, which will do the punching, and it will have its own thing, and we'll figure out how to do all the electrical connections. Or you put in the playhead, which will play the music back. So the idea is, and there are a surprising number of people who are interested. As I've kind of gone around, there's been a lot of people who've made automated paper stuff. There's websites like musicboxfanatics.org and whatever. So there actually might be a market for this as something that is a place where you can download a MIDI track, basically, and that I've found websites that basically have MIDI tracks that get converted to DXFs so that you can punch music, and things that are like arranged for this. They have songs for it. So, but the idea is that whatever controller is living inside this box will have an interface for it, a human interface right here. Actually, it would be on this side of the box, but I haven't mirrored that yet. And if you plug this thing in, you'll be able to insert an SD card into it, and then this thing will shuttle back and forth and punch your music for you. And between these two rollers, it'll advance it for you, and you'll be able to put a big. You can get the music box paper in a big spool. So I'm going to make sure that the spool holder here is compatible with the size of the spools that they sell. And then you'll have a way of both punching music and playing it back. That's the idea. And we'll reuse between those two different things. We'll reuse a machine interface. We'll reuse the Arduino that's in there running it, and essentially reuse the paper pulling mechanism for both of these machines. So that's kind of the idea. I was talking with Joran. I don't know, shout out Joran if you're with us on YouTube. Yesterday about this punch head, and the idea here is that we have a spring-loaded thing, and it will basically we have a solenoid which will pull this guy, and this is a cam. So basically, this first little bump down will bring the punch into contact with the paper, and then I have a very slight angle. At first, this is where the punch is going down and going through the paper, and then I have it basically punching all the way through, because you want to be able to push the paper. I haven't made the hole in this die yet. We need to be able to push the paper all the way through this die to clear it. Otherwise, you're going to be pushing a bunch of paper and packing it into a hole, and it's going to foul. So you need to get the punch all the way through. So that means we have a total stroke length for this thing of 7 millimeters, and the idea here is to use this solenoid to turn 1 inch of throw into 7 millimeters of travel, and to have it not be exactly linear, but to kind of use the travel of that thing to exert the most force when you need it, and then to speed it up. So that's why I have this kind of it's kind of like a cam, but sideways. And anyway, but all that stuff said, I have no idea if the solenoid is going to be strong enough to do this. There's obviously a lot of friction built into this solution. I don't know how I'm going to mount it yet. I had a mounting plate behind it before, and I didn't like it, so that's why it's not there right now. So it might be that we go with a gear motor and an actual rotary cam. Anyway, so that's kind of where we're at, and still brainstorming on that front. You have any constructive criticism for me there, David?
No, it's looking good. I think once you get this a little bit more refined, you might find that attempting to model contours in your layout sketches are probably I don't know. I think it's probably a bad idea, but I mean, obviously, you probably won't get into too much difficulty with that here because it's not a giant machine with a lot of parts, right. So you should be fine.
Yeah, and there is something a little bit different between this project and the MMX, which is that MMX we're mostly going to be, I would say, curating designs which have been designed and prototyped outside, and they're kind of already almost done, at least on the concept level, right? They're going to be pretty much done conceptually by the time we're doing it here. Here, I am laying things out, and I'm doing a lot more iterative, what is actually going to work and what isn't. So you can see, like, this, I have in this sketch, like, these lines are part of the outline of the kind of plate. I was going to sandwich these functioning blocks in between two plates of aluminum, so it would just kind of auto line itself up. I don't know if that's going to work. I tried it that way. It looked big and bulky, and I didn't like it. So yeah. So I still have to work with that.
That's why you have CAD.
yeah, exactly. So anyway,
the only other concern I have with what I've seen so far is probably generally only do a revolve if I know I'm revolving bar stock.
Mm-hmm.
I saw that your wheel is a revolve, but you're really making that probably out of some kind of
The hub is a
sheet
revolve.
good.
I believe the hub is a revolve.
Yeah. Okay. I thought I saw a big revolve profile in your layout sketch for the wheel.
No.
Oh, I'm certain I saw something like that.
Yeah,
Well,
I think you were seeing. I think you were seeing the hub. It's right there, right above the side plate.
Well, what geometry defines the wheel?
It is. Let's look at it. So here, we have a sketch there. So I do have a patterned revolve pattern for these spokes. I do have that.
No, I saw it from the YZ profile. You had revolve profiles.
Yeah, so that's just how I did the reference geometry for the wheel. So the reference geometry that I thought was really important for the wheel was all on this plane. So I didn't do a revolve, but I did set it up like you would do a revolve. That's what you're talking about, right?
Yeah, that's what I saw.
Yeah.
Mm-hmm.
Yeah, so I didn't actually draw them.
Yeah, I would caution against that.
Yeah. Well, I didn't actually make the parts from that, but, kind of in thinking of it, this was the plane. Like, if you try to, like, pattern the spokes or anything else like that, it doesn't really matter. The things that are driving this is, A, the thought that the paper is going to live in this trough in between the two things rather than on the wheel like the previous versions had. And then, where the side plates were going to be. And, so here I was able to basically lay out the key features of both these spokes, the thickness of the side plates, and the hub, and have them all work together in one sketch. I thought that was just the most elegant way of doing it, essentially. But you're correct. I did. It looks like that is a revolve profile for sure. Like, if you were going to make all these things with the revolve, you would lay it out that way. But this is just the reference geometry for this subassembly.
Right. I just, for your own visual, I guess, or do you link other geometry to this sketch?
I do. So if you look at the side plate and that geometry, it references down to here. Even the plane that I'm doing references down to there.
Yeah, I would caution against that. A lot of dependencies, really, especially between. So I know what you're trying to accomplish. You want it all saved in one spot, but that's what global variables are for. If you need it for your own visual reference, like, it's probably not a bad idea to keep around. But in terms of having a sketch like that, you almost had it, man.
I know. I don't know why it doesn't want me to drag this stuff up.
Oh, you see the arrow?
Yeah.
There you go.
Yeah.
So, it doesn't matter where your mouse.
How would you have done the sketch geometry that's specific to this part, right? This is the complete assembly, right? So I only have the two side plates, the hub, and then the things, right? They're going to be on top of the support for the paper wheel, which is going to be its own subassembly, right? So how would you have laid this out where you could capture, all of this geometry?
Right. Well, so your hub is going to have, distance between the bearing races, etc.
Mm-hmm.
So, that information you either keep in the hub, and then that's where it lives, or you put that in a global variable above it.
Oh, so you're saying not even have it in a sketch, but just develop your variables, like your offsets from the front plane. So then you wouldn't have.
Right.
I see. You're kind of like just doing it with the other thing.
Yeah. So basically, I would caution again, if you find yourself making a sketch and it has multiple sketch profiles, that's like a red flag that you're probably kind of going down the wrong path.
Right.
Or if you're making a sketch that like you don't ever intend on doing anything with, that's it's kind of, that has sketch profiles in it. That's kind of another red flag. It's I see it a lot. I just had I don't know if anybody wants, if you're watching this, if you want to go in CAD team chat. I just had about an hour and a half chat with a guy, and NewsX actually, about this exact topic, where like this is a philosophical difference, and in Fusion, I guess that's just how you guys are doing it. But it's this this quest to make your timeline shorter for some reason, and I understand, because you think by extension, pardon the pun, the timeline being shorter will lessen the processor load, right, on the machine. So you want to get as much stuff in one sketch as you can.
Yeah,
and
well, I don't think
literally it's the opposite of what you want to do.
Yeah, well, no, I don't think it's about processor load. I think that people are doing that because when you look at a part or an assembly that has a huge timeline, it's really hard for anyone else to go into that part and understand what's happened, right? And that's just an artifact of how Fusion works with their timeline. It's just like, what the hell is this? When the timeline's that long, you've kind of let things get away from you, I think. It's just more to manage. I
totally think the exact opposite. I think that when you have one sketch and a whole bunch of things that use that sketch, you're talking about, imagine that you have to change something, right?
Mm-hmm.
And because you have 10,000 sketch contours in your sketch, and you need to change something, and all of a sudden one of those sketch contours disappears because a line moved or whatever.
Yep.
Now you have to. It's like a complete mystery how to fix that. It's just a bad idea. It is. I hate to harp on the guys that are doing it, but
well, no, I hear you. I think the differential,
what I just discovered is it's deliberate.
Yeah. Well, I think the differential here is that if you're in Fusion and you're doing that, but let's say everything you're doing, all those features are for one part, right? Then I think you're fine, because you're basically making your design for that part a little bit more granular, right? But if that same design and all those features,
I disagree with that too.
Well, okay. Well, I'm thinking that's what you were saying, so maybe I'm misunderstanding you. But if you have multiple bodies and multiple subcomponents, and your timeline is going in between them, which also means that your references and your dependencies are probably going in between multiple parts that are siblings, essentially, like what we were just talking about, it shouldn't be doing in SolidWorks, then I think that's super bad practice.
No, I think it's bad practice 100% of the time. If you have multiple closed sketch profiles with the intention of doing several extrudes from it, then you're doing it wrong. Like if you have layout sketch that has specifications for those things, that's one thing.
Yeah, I'm
right?
with you on that.
But you went ahead and sketched your extrusions and your revolves in your layout sketch. First of all, that's a bad idea. But then
this guy
also having but that revolve profile right there that you're using as a reference, there's got to be a dozen sketch profiles in that. Again, that's a red flag to me, because really all you really need to know is that offset. You need to know the width of the trough. You need to know the diameter of the plate that thing will be made of, and that's all global variables.
Yeah.
If you need to see a visual representation of that, that's one thing. I get it, and you can draw it for your own visual purposes. But to use that as a data container, I
see what you're saying. Yep.
Asking for trouble. Yeah, that's why they have global variables.
So fully guilty, right? If you look at this sketch we're talking about, all the data's here. I did not do global variables on this, right? So what you're saying is that this sketch is more than is necessary, right?
It's just unnecessary. Yeah, right.
Same as doing it I would compare it to programming. Like if you're doing everything with one-liners, sure. The whole code is shorter, but it's not readable and it's not understandable because you're doing too much at once. If you do one thing at a time and you define your variables clearly and name everything correctly and everything, then it's clear by itself and you don't need any comments. That's the difference.
Yeah.
Like you're squishing too much into one slot.
Right.
Yeah. So I was using an example in Cat Team chat this morning in this really long conversation I had. I mean, don't get me wrong, you and Newsix are on the same page with this. Like you both just exact same words and phrasing.
Right.
I just disagree. I think it's a bad idea. I think it's just it's so easy to destroy your model without realizing it. And the worst part is going into fixing it again afterwards. It's like you have no idea where to start because is the leg bone connected to the ankle bone or is it not? Well, I don't know because there's the ankle, the arm, the toes, it's all in the same sketch, and you're like, and it's all connected to like this thing. And so I used an example in Cat Team chat this morning, just a couple hours ago. If anybody's in there, you might as well look at it. It's the crank wheel, and somebody did a sketch with literally every single thing in the crank wheel from the XY or whatever plane you guys are using. I think it's ZX or ZY. I can't remember, but literally everything. And so there's got to be 50 or 60 sketch contours in it, and if anything changes, you're just screwed. And not only that, but like, because everything's in the middle, all roads lead to Rome. The origin is right in the middle is where all the circles are. There, like you can't even see the center point anymore because there are like 80 like sketch lines that construction lines that come out of it.
Pull it up on your screen
so that we can. Something. It's impossible to change anything because everything is related to everything in one sketch.
Yeah. So I don't know you want me to find it?
Yeah, why not? Now we're watching YouTube.
Okay, so
me watching YouTube on you. You watch. Inception.
Okay. So
there we go.
Where is my? How do I? Oh, right. Where is there? Okay, Cat Team.
Well, on the right, is that your that's your SolidWorks version of the same thing, right?
Okay. If I click another chat room, do I leave? Oh, there it goes. I don't know why it took so long. Okay. So can you see my screen?
Yep.
Okay. So this is the sketch in question. Yeah, it's not the worst one I've ever seen. I've seen worse. This one is actually slightly palatable in a way. But if you look at the number of sketch profiles, there's the outside one, and then you go in and like, okay, well, there's the part for the handle connect, and then all of a sudden now you got to the small one, so now there's a little teeny weeny one here.
Yeah.
And then this part here is used for both. This is the outer one, but it's intersected by this arm, and then you go into the inside, and there's all these hub lines, and then there's places where there should be holes,
all the fillets are in there too, and
but they have hole features.
But you know what though? When you showed me this one the other day, I looked at that. I'm like, I want that as a poster in my room. Like I know I get what you're saying in terms of like it being kind of difficult to manage, but like I just thought it was beautiful.
Yeah. Well,
it's
okay.
Like industrial art,
Sure. Let me show you what I do.
Yeah.
By the way, whatever we just did, that was not on YouTube. I don't know if the delay is long or whatever, but
yeah, the delay.
Okay. Can you see my screen now?
I can.
Okay. So this is the equivalent part in SolidWorks. It's actually not 100% done yet, but I'm going to go into my crank wheel big, which is the part that we're looking at. Okay. So this is the component that goes in that assembly. It is 6 bodies. So it's the 4 panes made of polycarbonate or whatever that stuff is.
Yep.
It's this cap and then this body. And there's a reason that it's set up like this. I can explain it later. But basically, this is the entire timeline for this. It's not big. There's not a whole lot of stuff in it. But let's go through one by one. So it starts with sketch 1. Sketch 1 is an extrude. It's literally just a circle. That's all that is. It defines the outside. And then I extrude it. And I extrude it mid-plane because that's how this particular component is designed. So that, and that's how you want to make gears, by the way. You always want to go mid-plane. Um, I popped the hole, but the reason I put the hole, come on. I actually have an ice pack under my computer. It really is kind of struggling sometimes. Okay, so I put the hole in now. Normally I wouldn't do that, but I put the hole in now because this is actually going to be used as an offset for the hub. So if I go in Sketch 4, this is where the meat is. This is where the money is made. So in Sketch 4, I pulled this geometry from the old one, the old crank handle, like right from Martin's original project, so that I made sure that I got it right. There's a couple of things I did change, like this radius is like point, but it's close enough to 125 that I'm just going to leave it there. It's not critical. It's aesthetic. But I used a 4mm offset. What do you call it? From the hub. That gives me a construction line. Or sorry, from the through hole. That gives me a construction line that I can then make another offset from, because in the end I want it to be 8mm. And if I do that offset first, then I can just offset the entire thing around.
Right.
So if I get rid of the first sketch and the first body, you'll see that it's literally, this is the entire sketch. It's this construction line and then an offset. Boom. And so I offset everything. And then once I offset it, I put some fillets in there. And the reason I put the fillets in first is because I'm doing it once. If I were doing a sketch with 800 of them, I wouldn't do it like this. But it's going to be patterned around, and it would actually be more work to do it as a feature next than to do it here. So I did it.
Do you have multiple radii of those different fillets or different radiuses?
They are. Radii. That's another reason. Yeah. Okay. Yeah. So
they're all going to be the same. I could see just doing one command after you revolve it, but yeah.
Yeah, but they're not. So that thank you. Yeah, that's a good catch, because that's really essentially why I did it. And then I did a single cut. I patterned the cut. So now I've got that. Then I just cut the top one off by doing a, what do you call it? Convert entities. So now I've got a sketch for this leg, which I then used some of the geometry to do this profile. And this profile is the positions for the handle, and then this guy that holds that connector. So once I did that, then I just extruded it back in.
I don't know why, but that really deep, kind of like just above the connector, and the fact that profile goes really in above the connector and before the three handle positions, it just seems to me really weird that contour goes that far in. It just looks weird. Anyway, go ahead.
This oval?
No, above that.
This?
The little inlet above it. Yeah, there, the Gulf of Tonkin right there.
I think it's like that in the original one.
I know.
It's
I'm
close.
Just thinking it's just a weird design choice.
Yeah. So I'm not in Martin's head or whoever designed this back when they did, but actually it's kind of a fortunate thing, because when the handle is straight up, you'll notice that this thing is just very slightly forward of 12 o'clock.
Mm-hmm.
So what that means is that from the default position, if you mash down on the foot pedal,
it's going to go forward.
Then it'll actually exactly. And I don't know if that was an accident. I don't know if that was on purpose. But I can tell you that if you compare that to this sketch, you would never figure that out. It's actually at a weird angle. It looks like it was captured, not at the, like, it was just captured in a weird position, and then somebody's like, yeah, let me just sketch it in that position, instead of sketching it in a vertical or horizontal orientation for some reason.
I mean, it was probably from a video frame.
Yeah.
Yeah, exactly.
Most of it was done.
Yeah. So there's some design intent that got lost in translation that you found just by doing the geometry differently.
Yep.
Yeah.
Basically.
So anyway, then I just, followed through. Computer's really struggling right now. I'm sorry, there's some delay. I think it's probably because of OBS and all that stuff going on right now.
So I actually turned when people were complaining about how pixely my the stream was. I had the stream set to ultra low latency, and the way that YouTube achieves that is by low, the latency goes down, but your frame rate and your resolution also goes down. So
yeah.
So I changed.
For me, it's more about heat though.
Now, but it's also, I think we're clipping less.
Yeah, it's not on your side; it's on mine. It's my computer's overheating.
But anyway, go ahead.
Yeah, the problems with SolidWorks have nothing to do with YouTube. Really, the problem I'm having right now is heat. I have a Xeon and a Quadro inside of a thin and light laptop, and it just can't like let the heat go fast enough.
Right.
So, okay, so then basically I just went on and did convert entities to get the inside profiles once everything was already cut out, and that gave me my plexiglass, which is what that boss extrude is.
Yep.
And then the next ones are just what was my sketch 12 here? Okay, so now that was the chip here for the countersink, and then for one last thing, I added an axis that is coincident with the top plane and the right plane, so that I have a mate reference later on, and that's actually what this mate reference is made from. And
let me see. You added an axis. Can you show us where that axis is?
Yeah, it's just coincident to the top plane and the right plane.
So that's all I did. Then I mean, so you can turn on temporary axes as well, right? Which will just give you the axis of any round feature. Why would you not rely on that?
But because if I make a design change and that hole disappears or changes to a square or whatever,
okay.
Now I've lost my reference. But I already know that this entire thing revolves around this axis, which actually doesn't need to exist until I use it later for reference.
Right.
So I could have put it at the top if I wanted to, but then I'm kind of against doing that because I don't use it for anything. And if I put it at the top and it's nothing's dependent upon it, then what's it doing there, right?
Right.
I just put it at the bottom and I say, okay, I'm closing out this design. I'm going to add this feature so I can use it for on. And now, I select it and nothing's dependent upon it.
But it's cool. So you're basically saying I'm going to give this a reference feature because I want the reference feature. You're being proactive about reference geometry, basically.
Yeah, and I could do it a different way. Like I don't need to give it an axis. I don't need to give it even this particular mate reference. I could do other things. Like I can use a coordinate system, and I can make a coordinate system be coincident with concentric or whatever around anything I want it to be, and I can use that as a reference too if I wanted to. And coordinate systems are generally more useful for CAM. That's really why you have them.
Yep.
But on the other hand, they work for mates in assemblies too. But the difference is that with these mate references, which you see in this selection here, those allow you to snap a part in with literally zero effort. All I need to do is drag it into the window, and it just populates in its exact spot instantly. Right. And because you've predefined where those things are. Fusion has a similar function. I don't know that it's as instant, but it's a very similar mate reference feature. And then you'll notice there's one last thing on the feature tree, and that is countersink. So this particular feature I did not do in this part. I did this part in the crank wheel assembly, and it populated back because it is a feature that is done in the assembly in order to put fasteners between components. So in this case, I'm going to X out of it. It's going to ask me if I want to update it. Sure, I didn't really change anything, but whatever. Ask me that if I want to update or rebuild the assembly. It does that. To my assembly. Okay, and so that countersink is actually right here. That's exact. I did it in the assembly, but it went up into the crank wheel, and so therefore, it's part of a feature under assembly features called hole series, and that allows you to do holes through multiple components at the assembly level. So then you can apply smart fasteners to it. So, yeah. So you apply smart fasteners to it. You could do it during the hole, or you can do it after. In this case, I did it after.
Right.
And
it
so
makes sense. I mean, if you
all of your fasteners,
you're bolting multiple things together in a subassembly, and you don't have to go and edit both components. You just change the fastener or change. Yeah, that's really super interesting. I didn't know I could do that.
Yeah. And so here's the smart fastener for that particular one, and I can actually go in and open the part if I wanted to. Generally, you don't want to because it's. Say again?
Can you zoom in on your model a little bit?